Hello, hello. Welcome back to Chapter 9. We're on Section 9.2 now. And I saw in the news last week, maybe the week before, did you hear about the cruise ship that left from Florida and they got caught in a crazy storm out in near the Bahamas? And there were waves coming way up on a ship and whatnot, and the passengers were freaking out. Anyway, there's a formula, a math formula, that if you know how fast the wind is blowing, you can calculate approximately how high the waves are going to be. So, to be able to understand this formula, though, you have to understand something about numbers, obviously. But today we're going to talk about real numbers. And what are real numbers? That's kind of the general term we use for every number that you know about. And then there's rational numbers, irrational numbers, and whatnot. So eventually we'll get back to square roots, which is what this formula involves. So let's get started, and we'll try to move quickly because it's kind of late on a Sunday night and I'm ready to get home, but that's all right. We have talked before, last class period, about rational and irrational numbers. And if you remember, so we're talking about real numbers first and foremost. Real numbers is basically anything that you could probably figure out where it goes on a number line. Okay? Could you probably figure out where the square root of 2 goes on a number line? Yeah, because you could just do that on the calculator and then you can know about where it goes. So you don't really need to think a lot about real numbers, except that basically every number that you know is a real number. Non-real numbers, there are such things, imaginary numbers, but that's later on for Algebra 2. So forget about that right now. So real numbers break down into rational and irrational numbers. Now, I told you before that a rational number, if it can be written as a fraction, so rational fractions, if it can be written as a fraction, such as 3/4 or 3.3333 repeating, which would equal 1/3, right? If it can be written as a fraction, it's a rational number. You can wrap your mind around it. And I think you might be able to remember now, irrational numbers cannot be written as a fraction, and these are non-terminating decimals, non-terminating and non-repeating. I've heard them called both of these, non-terminating decimals. For example, pi is irrational because it goes on forever in randomness. And the square root of 2 actually goes on forever in randomness. The square root of 3 would do the same. Let's see. You might, if you did maybe 5 divided by 6 on your calculator, it might fill up your whole little screen on your calculator with random numbers. But because it was actually 5 divided by 6 written as a fraction, you know that at some point is going to end, or it's going to have a pattern that goes on for forever. It would be a rational number. All right? So irrational numbers, you will not see any fractions over on this irrational number side. Okay, so let's use these a little bit here. They show you a little diagram in your book, and I'm going to move this thing. Oh, there we go. That's been bugging me this whole video. Okay, so that's basically what they explain here. Real numbers include irrational numbers, which we listed, square root of 2 and pi and whatnot. And then rational numbers. Now, included in rational numbers are integers. Integers are -3, -2, -1, 0, 1, 2. Okay, these are all integers, positive and negative integers. Whole numbers is anything from 0, 1, 2, 3 on up. That's whole numbers. See that? All right. These, by the way, can all be written as fractions, right? 2 is 4 divided by 2. 4 over 2, that can be written as a fraction. So, let's see what they got. I'm going to move the camera here for you. Classifying real numbers. So here's the number they have for you. Is that rational or irrational? Well, it's a fraction, rational. What's the decimal form? Cha-ching. What's the type of decimal? It's terminating. It ends. Okay? 1 over 11, rational because it's a fraction. It has a pattern. We call that a repeating decimal. It's still rational though. Okay? Now this one, square root of 3, cannot be written as a fraction. It's irrational. Goes on forever. So they are calling it non-repeating and non-terminating. Okay, so why don't you write it the same way? Non-repeating and non-terminating. Now, is the square root of 9, okay, let me test your brain cells here. Is the square root of 9 a rational number or an irrational number? Rational or irrational? Remember what we said about square roots. How do you find the square root of a number? This goes back to yesterday. Okay, pretend that there's a square and there's a 9 in the center. You know, make a little square around 9. If 9 was the area of a square, what would this length be and that length? Remember, they're the same length. That times that gives you the whole area. This is how we find a square root. It would be 3. Square root of 9 equals 3. And how many of you remember it can be positive 3 or negative 3? Right? So, can 3 be written as a fraction? Yes. 6 divided by 2, 9 over 3, you know? So, the square root of 9 is actually a rational number. So if they had square root of 9 here, it would say rational. It would be a terminating decimal because it would just be 3.0. All right, let's flip the page here. Let me move the book on down. We're going to talk about the cruise ship in just a second, but first, let's see if you could spot where to put some of these on a number line. Okay, square root of 2 and 2, which one's bigger? Well, the square root of something is always smaller than itself. The square root of 2 is some smaller number times itself to give you the bigger number. Actually, I think I need to eat my words there. There is a case when the square root of a number might actually be bigger. Do you remember between 0 and 1, if you've got a fraction, like 1/4? 1/4 is between 0 and 1, right? Well, if you square 1/4, not square root, but square 1/4, so 1/4 times 1/4, you will get 1 over 16, 1/16, which is smaller than 1/4. So the square root of 1/16 is actually bigger than 1/16. Okay, let me show this to you. Just make sure you got this. 1/4 times 1/4, or 1/4 squared, parentheses. 1/4 squared is 1/4 times 1/4, that's 1/16. Therefore, you just go backwards. The square root of 1/16 would equal 1/4. So, in this case, in the case of a fraction between 0 and 1, the square root is going to be bigger than what's actually inside the radical here. Remember, this is called a radical sign. But in most situations, we're not finding square roots of fractions. Usually you see square roots of whole numbers and whatnot. So, in this case, the left side here is smaller than the right side. And you can figure that out on the calculator, and that's going to go right about there on the number line. All right, and that's what they have here. Second question, square root of 1/2. What is the square root of 1/2? What times itself would give you 1/2? Well, do that on the calculator. It looks like it's going to be this. 0.7071 approximately. And that's actually bigger than 1/2 itself, which is 0.5. And so that's going over here on the right side of the number line. 0.5 is here on the left side. And so square root of 1/2 is greater than 1/2. Okay, simple enough. Let's look at this one and then we'll talk about the cruise ship and be done. Order the decimals. La, 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 from least to greatest. Okay. Well, this is 0.47777 repeating, right? This is 0.4, you see this? 74474. Which one is bigger out of these two? The top one is bigger, right? Because this goes 474, this one's 477. So that one's bigger. 0.47 repeating. 474747. Okay, and then 0.477. So I'm going to just list these. Let me zoom in on this a second. Woo! Okay, you can see that. Number one, the biggest one. Let's just say number one, the largest number here. What's after this? This is going to be 0, 0, 0, right? There's just zeros after that. The largest one looks like this top one. That's number one. The second largest one, 474, 474, 477, is going to be this one. Third largest, 4747, 4744. There's the third largest right there. And then that's the smallest, the fourth one. So you can order those out on a number line if you want. And look how they solved it. They basically listed out exactly how I did and noticed the pattern and which one, this one's bigger than that one, this one's bigger than that one, so on and so forth. Okay, now, by the way, when you do your answer, look how they put it right down here. Gonna get all close on it, okay? They listed these answers in the same way that they were listed up there in the actual first problem. Okay, so make sure when you list these in order from least to greatest, you put them in their original format. See here, original format. Thank you very much, otherwise you might get docked points. Alright, let's check out this cruise ship. So, on the open ocean. For large ocean waves, the wind speed and the height of the wave, they're related. So, guys, you might not really get this yet, but with math, you can use formulas to relate different real-life things. So wind is a real-life thing, and the faster wind is going, the bigger waves are. Well, they're not related like one-to-one, like if the wind is going 1 mile an hour faster, then the wave is 1 foot higher. No, it's related through a little more complicated formula, but still, they're related. So here's the formula. If the wind speed is s, which is in knots, the height of the wave will be given here. Or if the height of the wave is h in feet, the wind speed will be given there. So, let's see what the question is. If the waves are about 9.5 feet tall, look at this cruise ship. If the waves are 9.5 feet tall, what do you think the wind speed is? It says here 1 knot is equivalent to 1.15 miles per hour. So, stick the 9.5 in there. On your calculator, you would do the 9.5 divided by the 0.019, which gives you 500. Then you do the square root of 500, which would give you plus or minus 22.36. Now, approximately, right? That's what that symbol means, approximately. I'll put a little approximately symbol. Now, what must the wind speed? Can wind speed be negative 22.36? No. So forget about the plus or minus. It's just positive 22.36 Miles per hour? No, knots. That's what they have there. All right, that's radicals, and that's the real number system, rational and irrational numbers. Talk to you later.